And what's our other objective? Systems of equations. I can name the 4 methods for solving a singular system of equations. Okay. Okay, and then someone give me, what is an example of an opposite or a definition of opposites? Multiplication and division. Someone else? Add and subtract, good. Okay, anybody else? So obviously like tall or short, positive, negative, yeah, good. Hot and cold. Tall, I already said that, tall and short. What else? Big and small, yeah. Yeah, and then how do we use opposites in algebra? You guys were kind of touching on it when you started talking about the different operators. But how do we use the opposites in algebra? What do we do? Brooklyn, what do you think? Yeah. Yeah, and yeah, exactly. And that's when we're solving equations, right? When we're solving equations, we use opposites to find the value of the variable. So, yeah. We use opposites in algebra when we solve equations. We solve equations. We use opposite operators. Use opposite operators. All right, and still kind of on the same topic, I want you to write down the additive inverses of these numbers. So I reminded quite a few of you, additive inverses are just going to be like the same number, but the opposite sign. So if something is positive, the additive inverse would be negative. And when we add 2 numbers together who are additive inverses, their sum is always going to be 0. 3 plus negative 3, 0. Negative 10 plus 10, 0. They cancel each other out to be 0. Okay, so we use that a lot when we're solving equations, right? And we're going to use that same idea to help us do this elimination method. Okay, so let's go through and we'll name the additive inverses here. Okay. So for negative 2, the additive inverse is just going to be the same number, opposite sign. So that means it's positive 2. How about 6? And 10? Okay. Someone else? Mauricia, what about 5x? What do you think? Yeah, negative 5x. Okay. Okay, in Brooklyn, what about negative 4f? Yeah, positive 4f. Okay, and then Alex, the last one. So the one that I gave you is positive 9p, so what would be the, there you go, yeah, negative 9p, perfect. All right, and now this is just the definition for the elimination method. So I'm just going to go through it. The elimination method, and you can see how many you guessed right. Elimination method is a method for solving a system of equations that involves adding or subtracting. Adding or subtracting the equations to eliminate a variable. To eliminate a variable. And in some cases, both sides of one or both equations must be multiplied by a number before the equations are added or subtracted. Okay, let's go to the next page. We'll talk about the rules, what we need to do when we're solving a system of equations using elimination. So the first thing we do is, if necessary, we don't always have to do this step, but if necessary, multiply the equations until a variable's coefficient set. Coefficient set. So I'll explain what that means. So for this system, 2x plus y equals 10 and 5x minus y equals 18, the coefficient set of x would be 2 and 5. Those are the coefficients of x. What would be the coefficient set for y? 1 and negative 1. 1 and negative 1. That's x and that's y. So the coefficient set is just saying, looking at the coefficient, the number being multiplied by the variable we're looking at. So we want the coefficient set of one variable to be equal with opposite signs. So that's like saying we want them to be additive inverses of each other. So just looking at this example again, is the coefficient set for x, are those additive inverses of each other? 2 and 5? No. What about for y? Yeah, 1 and negative 1 are additive inverses. They are equal with opposite signs. When we add 1 and negative 1 together, they get 0, right? Okay, so that's the first thing we need to do. We need to make sure for one of our variables, the coefficient set is equal with opposite signs. They're additive inverses. Our second step is we're going to add the two equations together vertically. And what I mean by that is saying, like, instead of doing 2 plus 3 equals 5, we want to add them 2 plus 3 equals 5. That's what I mean by vertically. But we're not going to be adding numbers together. We're going to be adding equations together. Okay, so you'll see more of that in a minute. And then solve for the remaining variable. And then at this step, it's really similar to substitution, where we just solved for a variable, so we take that value and we substitute it in to one of the original equations. So we substitute the value we found in step 2 into one of the original equations. And then we need to solve for the remaining variable. And then like what I did with that substitution problem, our last step is to check ourselves. And you can do that by plugging in the value for x into x, the value for y into y. And just another reminder, our solution is always written as an ordered pair, x comma y. Okay. So we're gonna do a couple problems together, and then I'm gonna have you try and work on it a little bit on your own. So first one is a word problem where we have this guy, JP, is thinking of two numbers, and he won't say what they are, but he tells us that the sum of the two numbers, remember sum is added together, the sum of the two numbers is 163, and that their difference is 33. Difference. What operation does difference refer to? Plus, minus, multiply, divide. Subtract. Difference. Like, think about if I said, like, what's the difference in height between me and Adriana? We would take one of our heights and subtract the other one to find the difference. Okay? So we want to first write a system of equations for the sum and the difference of those numbers. And then we want to use the elimination method to solve this system. So let's write our system of equations. So we have two numbers that we're looking for. We have two numbers we're looking for. Let's call the first one F, F for first. So F. And then the second one, we'll call it S for second. First and second numbers. And we know that the sum of the two numbers, so that would be F plus S, we know that that equals 163. And the difference of the numbers is 33. How do you think I would write an equation to say that? The difference of the numbers is 33. What would I do? Yeah, F minus S equals 33. Okay, so now we have two equations working with the same variables. That means we have a system of equations. And now we're going to solve that system using the elimination method. So let's look at the coefficient sets of both of our variables. What are the coefficients of F? Of F, what? 1. Yeah, just 1 for both of them. What's the coefficient set of S? 1 and negative 1. That means that for one of our variables, we have the coefficients are additive inverses, right? So if I added S plus negative S, what would I get? 0. So that eliminates one of my variables. Okay, so let's do that. So we're going to move on to the second step for solving a system by elimination. And I'm going to add my two equations together vertically. So I'm going to rewrite them. F plus S equals 163. And I'm going to add F minus S equals 33. So what is F plus F? 2F. And then we already figured out what's S plus negative S? 0. So 2F equals, what's 163 plus 33? Good job, yeah, 196. And now how do I solve for F? Yeah, divide by what? Divide by 2. So if I divide this side by 2, I also divide this side by 2. 2F divided by 2 is just 1F. So F equals 196 over 2, 98. Okay, so F is 98. That just took part of step 2, where we added the two equations together vertically and then solved for the remaining variable. Now we take that value that we just found, F equals 98, and we plug it into one of our original equations. So let's plug it into the first one, into F plus S equals 163. If I plug in 98 for F, I get 98 plus S equals 163. And then to solve for S, what do I need to do? Subtract. Yeah, I subtract 98, subtract 98. Minus 98 gives me 0. So S equals 163 minus 98, which is 65. Good. So now I found my answer for F and for S. F and for S. So what I want to do now is just check. I just want to check myself. So 98 plus 65 should equal 163. I'm going to check that. And then I'm also going to check that 98 minus 65 equals 33. So let's check both of those things. Oops. So 98 plus 65 equals 163. 98 minus 65 equals 33. I just checked my solution. That's correct. So that's it. I'm done. These are both right. So F, my first number, equals 98. S equals 65. And that's going to be my solution. So when we're using variables outside of X and Y, you can write your answer just like this. But if your answer is X, or if your variables are X and Y, then we want to write it like an ordered pair, X comma Y. Is that clear? Cool question so far? How do you feel about this? Yes, no, maybe? Okay. So let's go on, we'll do the next page together. And I'm just going to do one of them with you today, and we'll save the other one for tomorrow. So we're going to take a look at number 1 over here. And then with the rest of class, I'm going to have you work on the back side of the page. Okay? So our first one, we've got 2x plus y equals 10. 5x minus y equals 18. What is my coefficient set for x? 2 and 5. Are those additive inverses? No. What about y? 1 and negative 1. Yeah, are those additive inverses? Yes. Y minus y is equal to 0. So our first step is taken care of. Let's move on to the second step where we add these vertically. So I'm just going to draw a line underneath them and add them up. So we start over here, 10. Let's start on the left. 2x plus 5x gives me what? 7x. Y minus y gives me 0. So 7x equals, what's 10 plus 18? 28. Now, how do I solve for x? Divide by 7. Divide the other side by 7. 7x divided by 7, that's 1x, equals, what's 28 divided by 7? 4. So x equals 4. And then we take that and we can plug it in to one of the original equations. So let's plug it into 2x plus y equals 10. But instead of x, I'm going to write 4 this time. So 2 times 4 plus y equals 10. 2 times 4 gives me 8 plus y equals 10. And now how do I solve for y? Subtract 8. Yeah, subtract 8. But if I subtract 8 from that side, I also have to subtract it from this side. 8 minus 8 gives me 0. And y equals, what's 10 minus 8? 2. So I just found an answer for x and an answer for y. Let's go through and check our answer. So I take both of my equations. Let's do 2x plus y equals 10. And I'm going to plug in 4 for x, 2 for y. So 2 times 4 plus 2, does that equal 10? 8 plus 2? Yeah, that works. And now let's do the other equation, 5x minus y equals 18. 4 for x, 2 for y, so 5 times 4 minus 2 equals 18. What's 5 times 4? 20. So does 20 minus 2 equal 18? Yes. So our answer is going to be 4, 2. Okay. So now flip over to the back and let's work on number 3. Let's work on number 3.